We've been talking about earthquakes and seismic waves. As we know, earthquake is the shaking that happens when there's movement of rock alongside a fault. Earthquakes take place deep inside the earth. The area can start as in the earth, and then this area right here where it starts is called the focus. Okay, and then the area above it that's on the Earth's surface, right here, is known as the epicenter. Now, the epicenter is always directly above where the focus is because of how the waves travel. So it's right here. Okay, so it's the area that is directly above the focus. And then there are three types of seismic waves that happen. They all occur at the same time, but they all travel differently. So we're going to go to a new slide. We have the P wave, which stands for primary wave, and it has kind of like a push-pull movement. We used a slinky in class so that we could see how these waves would travel, and we could see how the slinky was compressed in its springs. Then we also have the secondary, or the S wave, and these move through the surface like an S. Like we use the example of if you're playing that jump rope game when you were little, and you would you would have the jump rope on the ground and move it really fast and you couldn't touch it. That's like an S wave. And then the last type of wave, and our science book uses these words, is a surface wave. And they move kind of like in a rolling motion. P waves are the fastest, so they are always the first to arrive at a seismograph station. The S waves are they're slower than a P wave because of the way it travels. And also an S wave can't travel through liquids, so it can't go through the mantle. Okay, so it can't, only solids. And then last what we have is the surface wave, and it travels through the surface, and it's the last wave to arrive. The last wave to arrive, last wave to hit. That's how we describe them. I really liked this image for comparing the three different types of scales or ways to measure an earthquake. So the first one is the Richter scale. It's located right there. It's used to measure the strength of the earthquake or the magnitude, and it goes from 1 to 9. We also talked about the modified Mercalli or the Mercalli scale, and it has 12 scales, or 12 levels, and it has more to do with somebody's perception of what they're feeling or what their observations are. And finally, this is like the one that is used most today. It is used to compare the size of the earthquakes when the Richter scale is not so accurate. Scientists, or if you hear news reporters reporting an earthquake, this is the one that they use. However, a lot of times they accidentally, or they don't realize that they're saying, they use the word Richter scale when they really mean the moment magnitude scale. Here are three main points. It says here the Richter scale tells us how strong it was by seismographic readings. Modified Mercalli measures the intensity felt of an earthquake, and this is like the most specific one. And they say it's because the Richter scale it doesn't work well for large earthquakes or for far away earthquakes. So this one is the one that is mostly used. Finally, we talked very specifically how you have to have, in order to find out where an epicenter is located, you need to have 3 seismograph readings, and those you'll be able to use those to measure the distance or the difference in time of a P wave arrival and an S wave arrival time, and that would help you calculate using a scale on a map how far away that seismograph machine was away from the epicenter. So when you have 3 seismographs from 3 different locations, it will allow you to pinpoint where it is. So because it'll be where all 3 circles intersect. So here's one circle, and when we said it was from one seismograph station, it would be anywhere. The only thing you would know is it's somewhere on that circle is the location of the epicenter. Then we have one over here. So now we've narrowed it down to either this is the location, let me change the color, either this is the location of the earthquake or this one, but that doesn't tell us exactly where it was. So we need one more seismograph station, and it's where those three have intersected, which is right here. That is where the earthquake has occurred. You need 3 to do the triangulation.